How do we implement loops in Rust? It's often useful to execute a block of code more than once. For this task, Rust provides several loops, which will run through the code inside the loop body to the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. So Rust has three kinds of loops: loop, while, and for. Let's try each one. So we have three. Wow, this is different. There's one called just loop. So repeating code with the loop. So there's a new thing over here, which is loop. And the loop keyword tells Rust to execute a block of code over and over again until over and over again forever, or until you explicitly tell it to stop. As an example, change the source main file in your loops directory to look like this. Basically, I think this is a forever loop. So when we run this program, we'll see again printed over and over continuously until we stop the program manually. Most terminals support the keyboard shortcut Control-C to interrupt a program that is stuck in a continual loop. Give it a try. So let's give it this thing a try. It's super easy. All we gotta do now is essentially create a project. Let's go back to our directory, which is over here, and we go back to our VS Code, which is over here, and we also go back to the CMD. So I remember there was this code which is called cargo, and I believe we have to make a project, right? So cargo build, I'm not sure, but let's see. And then we'll call it loop. Okay, so it's expected argument loop. Okay, it's not that. So how to build or how to create a project. Create a project using cargo in Rust. Okay, and it's just going to tell you. So it says over here, yeah, it just gives you the same exact thing. And over here it says the following command. It says over here, this one, cargo new, and then we have the, so that's the command. So we're gonna have to do this. So cargo new, and then we have loop. Okay, so I believe it will just call it loop. It says over here just it just says called loops. Okay, we'll just put an S. Okay, so now we created a new project. You can see that it's gonna appear over here as well. So it's right here. Let's go into it. So we could say cd loops, and in here what we're gonna do is code dot. Now this is gonna open it up in VS Code. So you could see over here we have the source and main.rs, which has the hello world. Now we could simply just run that hello world, simply saying like cargo run. So cargo run will just run hello world. But what we want to do now is we want to change it by giving this infinite loop and actually just putting it in this main logic. So right here, replaced. Okay. So let's run this and say cargo run. Okay, so you could see what's happening here. This is being printed over and over and over again. So Control-C will make it stop. So that's the infinite loop. So returning values from loops. Here's another one. So let's just copy it. Let's just write it this time. So let's go here, and it's a good practice to write. So I would recommend trying to write the program. So right here, it's a simple returning values from loops. So let's see what happens here. So we have a function which is main, okay? And then in here there's this block which has loop, but over here we have let mutable. Mutable means it's changeable, okay? So mutable counter, this counter could be changed and we make it assigned to 0. Okay, and then after that you can see that this is now an I32. You already know it's an integer. And then we have and let result is equal to a loop, okay? And then that loop has the following things inside. You basically have to put a semicolon here, but you can see that this result equals to a loop, and the loop basically has the counter incremented by 1 every single time. This plus equal to 1 means you could understand that it's counter plus 1, like that. So essentially I write it like this, pretty easy way to write. Okay, and now what we're gonna do is we're gonna say if the counter is equal to 10, what we're gonna do is we're gonna break the loop. So we say break the counter. Okay, so I think counter multiplied by 2. This is something new, but let's see what happens here. So counter multiplied by 2, and it's gonna break the loop, what I assume, and then there's this print ln exclamation, and then it says over here. Okay, so it says over here the result. The result is, and then we have inside. We don't basically. We could do that way, but like this. Just put the result inside these squiggly brackets and semicolon. Okay, I didn't spell it right. Now it should work. Okay, so what I believe here is that this is double click to insert. I don't know what. Okay, so you essentially could put that. Okay, but I'm not gonna put it. It's just giving you a hint. Because I have this extension on, and that's why it's saying that. But at the end, you could just look at it and simply say, okay, so it's gonna be 1, the counter, and then it's not gonna go, it's gonna go till 10. So the counter will go till 10, and then and you essentially have, when the counter is till 10, right? You'll have break counter multiplied by 2. So counter will basically have 10 and then multiplied by 2, which is 20. So the result variable will include 20, which is like the return value, which is saying returning values from loop. And then the result is 20. So I believe it's going to be 20 as the answer. Let's run it and see what happens. So we just say cargo run, and you can see over here the result is 20. So this is great. That's essentially what happened. So loop labels to disambiguate between multiple loops. Okay, so if you have loops within loops, break and continue. Break and continue apply to the innermost loop. At that point, you can optionally specify a loop label on a loop that you can then use with break or continue to specify that those keywords apply to this labeled loop instead of the innermost loop. Loop labels must begin with a single quote. Here's an example with 2 nested loops. So we have some specific things, like some fancy stuff here, and I'll just explain what's happening here, to be honest. We have function main. We have a let mut, which is mutable, count is equal to 0. Over here we have counting up, and then we have this call-in loop. So what is this? There are labels, loop labels. If you have loops within loops, break and continue apply to the innermost loop at that point. So we know about break and continue, and just 1 second. Just let me show you what's happening here. So we have this thing, this entire block, and then we have this print and count, and then we put the count variable. So essentially we're creating this count, which is 0, and then we have counting up, colon loop, and then inside this loop we have this count is equal to count, which is 0 right now. Mutable remaining is equal to 10, and then we have inside there's a loop here. Okay, so this loop is essentially from here, and it says print ln remaining, which is 10, and then remaining is equal to 9. We could break it, but if count is equal to 2, which is not right now, it's not. You could break counting up. So counting up, essentially I think it's labeled, so counting underscore up, and then we have, okay, one really weird thing is that there's this opening bracket, but there's no closing bracket for this. I'm not sure, but over here we have remaining is equal to minus equal to 1. So essentially if it's equal to 2, it just goes back, I believe, to this, and the remaining is decremented 1 by 1 until it goes till 9. So essentially I think it's breaking here, and then the count is gonna go up here, so that we essentially have it all the way to, I believe, like 2 or something. So this is like some code. If you have loops within loops, break and continue apply to the innermost loop. At that point, you can optionally specify a loop label on a loop. You can optionally specify a loop label on a loop that you can use with break or continue. Okay, so we have continue up. Oh, counting up. So we have counting up, and then also we don't have closing here, and we also have counting up. So you can optionally specify a loop label on a loop that can then use with that you can then use with break or continue to specify that those keywords apply to the labeled loop instead of the innermost loop. Loop labels must begin with a single quote. There you go. They begin with single quotes. Here's an example of 2 nested loops. And what it says, the outer loop has the label counting up, that is there. And it will count up from 0 to 2. The inner loop without a label counts down from 10 to 9. Okay, this one, the inner loop without the label. The first break that doesn't specify a label will exit the inner loop only. So this one, right? The break counting up statement will exit the outer loop. This code, okay, so this one will exit the outer loop, which is the counting up one. Oh, okay. The code prints this. So I just want to see like the working of this. So you actually run this code and it's gonna run on the bottom. That's crazy. So you can see over here it's running. So essentially what's happening is that we could also copy this. Okay, but we can see let count is equal to 0. We have counting up and then we have loop. Okay, so we have a variable which is count, and we also have a count which is 0 right now initially. Okay, so then what we have is inside, we go inside this loop and we say let mut remaining is equal to 10. We have this loop inside remaining is equal to remaining. So remaining is going to be 10. Okay, and then we have if remaining is equal to 9, we break, but we know if counting is equal to 2, we break from counting up. We're not going to break the outer loop either. So we decrement the remaining with -1, and we're still inside this loop. Okay, so we decrement by 1, and then we basically count remaining is equal to 9. So remaining is equal to 10 and remaining is equal to 9. And then look at this, count is equal to 1. Where is this going to be applied? So you can see remaining is equal to 9. And then if remaining is equal to 9, you could break this loop. So you essentially break this loop and you increment your count. So initially it was 0, it turns the count 1. And then once you increment your count, you go back to this loop on the top, and you can see the count will turn into 1. So that's why you have count is equal to 1 here. And then you essentially go back here again with remaining is equal to 10. So again, remaining is equal to 10, and go back in the loop and you say remaining is equal to 10. And then remaining is equal to 9, no. So you still can't go, and then minus, and then you essentially go back again, and then you have so remaining is equal to 10 again. Yeah. And then you cut your remaining to 9, and then you basically print these two things again, and then once it's 9, you break it again, and then you add the count from 1 to 2, and then you essentially go back here, up here, and you count the count to 2. So 1 and then 2, and then remaining 10, and then okay. So count is equal to 2, and then once the count is 2, right, you go back inside this loop again, and then the remaining essentially will be 10 again. You can see over here, and then you have if remaining is equal to 9, you break. But no, if the count is 2, you break counting up. So it is count 2 because remember it was 2 in this part, and once you break this counting up, you basically say break the outermost loop, which is counting up. With single quote, remember you have to do that, and counting up will be break. Will break over here, and then you essentially just cross this entire thing out, and you say end count is equal to count, which is 2. So 2. It would be end count is equal to 2. Awesome. So this is a really nice program. I would recommend practicing this one. It's really cool. It's really nice, and it's a good one to understand how essentially loops are working in Rust. So this is amazing. And we have conditional loops with while. So there's also this while loop. So essentially with while loop, it's normally like other ones in other languages, like if the number is not equal to 3, you just keep printing the number, and then you decrement the number. Number is 3, so number not equal to 0, you just print number which is 3, and then you decrement it, and then you print the number which is 2, then you decrement it, and then print the number which is 1, and then decrement it. And then once it's 0, you essentially say you just break it out. So you go lift off. So it's gonna be 3, 2, 1 lift off. That's 3, 2, 1. Yeah, lift off. So that's how it's gonna say. So I believe that's how it should run. It doesn't have that, but when I play it over here, it should give you 3, 2, 1, and then lift off. Great. Looping through a collection with 4. So we have a collection which is this, and we have mutable index which is 0. Index is less than 5. So index is 0 right now, but it's less than 5 obviously, and then the value of the index, so we have a underscore index. So we put the value, essentially say 10, 20, we just keep incrementing the index, so it's 0, then 1, then 2, then 3, then 4. And essentially that's less than 5, so it's going to increment the entire thing. You're going to see that what's going to work from this. So the value is like this. And then there's a new line that's being printed because we have print ln, so that prints a new line. Other than that, you know, you have this one, which is another way to do this. As a more concise alternative, you can use a for loop and execute some code for each item in a collection. So for element in A, you can just have this. This is super simple. And in C++, there is this concept as well. And I normally use, I call that as a for each loop, and that's the concept there for, normally used. So function main, and we have for number in 1 to 4 dot rev number. What is this dot rev? So it says over here, here's what the countdown would look like using a for loop and another method we've not yet talked about, rev, to reverse the range. Okay, so I believe this code is a bit nicer, isn't it? I believe what I think is that it reverses the number. So doesn't it go from 4? Okay, so what I believe here is that number in 1 to 4 rev, that reverses the number. So I believe what happens here is that 1 to 4 means start from 1 but not go till 4. So 1 2 3 4, 1 2 3, and then reverse the number, so meaning 3 2 1. Okay, and then essentially you have those list of numbers, and then you say 3 and then 2 and then 1, and then once that list is finished, you print out liftoff. So that's essentially what I think. Here's some questions that I really challenge all of you guys to complete if you're watching this video and you have reached the end. So try to convert temperatures between Fahrenheit and Celsius. Create a program. Use Rust to do this. Use C++, C, Java, any kind of programming language. I don't really, it doesn't really matter. But if you could do it in Rust, then put your comments, code in the chat, and I'll love to see it. Also, this is the second part, which is generate the nth Fibonacci number. It's also very important. So try to solve this using any programming language of your choice, and then print the lyrics to the Christmas Carol, the 12 Days of Christmas, taking advantage of the repetition in the song. So essentially, when there's a lot of repetition in some certain thing, you generally use some construct. And what is that? It's a loop. So you could utilize that. When you're ready to move on, we'll talk about a concept in Rust that doesn't commonly exist in other programming languages, and that's called ownership. And that's something super special in Rust. So stick around for this new video about ownerships later.